29, and yeah, we're going live on YouTube as well. So,
oh, right,
perfect.
Okay. All right,
yeah,
okay.
Let's start.
Okay. So, good evening and a very warm welcome to today's Community of Practice session. I'm nearly 3 years now. And with me, I have Neha, who is the director at Adhyayan. And along with us, we have Gauri and Annette today. A big shout out to them because they are the very, very silent workers behind the scene. They do all the tech work that is required at the back end, and they support us in all the webinars and the virtual sessions that we do. So thank you so much, Gauri and Annette, for all your very, very silent but very effective and efficient work. A little bit about the COP. So as most of you know, this was a forum that we started more than a year back. And this was for us to collaborate, for educators to come, collaborate, and learn from one another, and then come back and talk about your success stories and, of course, failures, so that we again deliberate on those issues and challenges to again understand what we could do to come up with solutions. And so that is how we've always had educationists, teachers, practitioners in the real life, in the real classroom situations and schools who have come here and then shared their real life experiences. And that's how this experience is so powerful and valid. And so we don't mind going and trying them back in our own schools. So, and I just want to say that we are delighted to see such a huge number today. It's a Saturday afternoon, yes, but then we already have 100 on the YouTube, on our live with Zoom, and then we have many more on the YouTube live as well. So this is a Saturday afternoon, but then this shows that there are so many educationists and school leaders and teachers like you, and who are all like-minded, and we are so passionate that we don't mind foregoing a Saturday afternoon rest and then coming here on this platform to be together and to talk about what works for our students. And of course, at this point in time, I also want to kind of take a minute and acknowledge and recognize the national crisis that we are going through today. It's not been easy. The last 1.5 months or so, starting April, has been so overwhelming for us as a nation. It has been extremely, full of anxiety, anguish, a lot of sorrow, and of course, a lot of physical, mental, and emotional distress to so many of us. And we've, in this process, we've had our frontline medical staff and doctors working tirelessly, and we have lost many of them to the virus. We have also lost so many of our educators to the virus. And at this point in time, my heart really goes out to all those students and their families who had this huge emotional turmoil during this time. And I'm aware, as teachers and educators and as schools, you've all been trying your best to reach out to your students and their families, to lend emotional support, and of course, I think financial support as well in many cases. But at this point in time, no amount of support really seems enough. But in the midst of all this, again, teachers have risen up to the occasion, and we've come out to be warriors because we have completed one full academic session, and now we are in the process of preparing for the next session. So, when we talk about, again, preparing for the next session, next academic year, what really kind of is important at this point in juncture is to look at the National Education Policy 2020. So that is something we cannot ignore at this point in time, because there are many state governments which have been telling that the implementation of this policy is going to be top priority in the coming session. And for most of us, we are aware of the national education policy, and one of the main focus points in this is the foundational literacy and numeracy. And hence, the theme for this 3-part webinar series, which is foundational literacy and numeracy. So the last session, a fortnight ago, was to do with what does good literacy learning look like. And today we are going to be talking about what does good numeracy learning look like. So at this point in time, I would invite Neha to play a short video for us. And let's just watch the video. And in the meanwhile, from now onwards,
I figure 75% to you, Pa.
Sorry, can I start that now?
Yeah, please start.
Okay.
And 25% divided between the 5 of us. Yida, Crowbar, myself, Tom, and the baby. That makes 5% for each one of us.
Billy, you're cheating yourself. If there's 25% divided among the 5 of you, that's 14% apiece.
Oh, no, listen, Pa. I wouldn't cheat you. You know I wouldn't. Now, look here. I'll show you. Let me rub this out here. And now, 25 divided by 5 is 5. You see, 5 won't go into 2, will it? No. But 5 goes into 25 5 times, you see?
Oh, you're wrong, Billy. Now, I'm a pretty good mathematician. Now, 5 into 25, 5 won't go into 2, will it?
No.
But 5 goes into 5 once. Now, we didn't use the 2 before, so we bring it down here. Now, 5 into 20 goes 4 times. There you are. 5 into 25, 14.
No, look, Pa. Let me prove it to you now by multiplication. 5 times 5. 5 times 5 is 25.
Really, I'm surprised you're learning.
Huh?
I'm surprised that you're learning. Now I'll show you. 5 times 14 is 25. 5 times 4 is 20. 5 times 1 is 5. 25. That's it.
No. Look, Ma. See, look, you're wrong there because I'll prove it to you. We'll put down 5 14s here. 14. There. Now I'll prove to you by addition that 5 14s is not 25. 4, 8, 12, 16, 20.
21, 22, 23, 24, 25. There you are. Better brush up, Billy. I don't want to see you boys cheated.
Thank you, Neha. So, yes.
I figure 75%.
Yeah, that was certainly humorous. Yeah. But if you look at it through the lens of an educator, what's there to say that our students may not make the same mistakes, may not think in the same way? So I'm telling this because whenever I look at this video, I go back to when I was in grade 2. And I was just learning division at that time, just started learning division. And I was so perplexed that for division, you had to start the operation from the left. Whereas till then, all the operations, addition, subtraction, and multiplication was always started from the right. So I couldn't just understand why. Why would you start only for division from the left? So that was so intriguing for me. And of course, I asked my teacher, and to my utter disappointment, what she told me was, that is a rule. For division, remember, it is a separate rule, and you have to start from the left. And if you don't do that, you will not get the correct answer. Wow. So, that was so disappointing. And of course, I did not buy that. Okay. So, but very clearly, this kind of reveals 2 things. One is, of course, as a student, I did not understand the concept of division. Okay. And I was not given the opportunity to understand the concept of division. All I was taught is this is the method. The second revelation is that this teacher was not trained adequately for teaching math. These were two stark revelations, which I can understand now. And of course, this was 40 years back, okay, when I was in school in grade 2, more than 40 years back, actually. But fast forward to now, and the Adhyayan data that we have through all the school reviews that we have done, again, shows how what is taught in schools in the name of numeracy. So in most schools, numeracy is equal to mathematics, is equal to the math textbook. And the teacher just ensures that the students are literally told how to do every problem in all the exercise from the textbook. So that obviously is the reason why the NEP has sounded a red flag for us. And according to the NEP, you can see on the screen, this foundational literacy and numeracy has become an urgent and necessary prerequisite to learning in our country. And there is a learning crisis because over 5,000 crore students have not attained foundational literacy and numeracy. And so it has become an urgent national mission that every student by grade 3 attains foundational literacy and numeracy, and that is going to be the highest priority of the education system in our country, and we need to achieve this by the year 2025. Okay, so that again brings us to the theme of this webinar and today's theme, which is what does numeracy learning look like? And so for this, we have three very esteemed panelists today. And the three of them are extremely experienced and very, very passionate educators. And I'm going to take a little time introducing their background and all that they have done in the field of education. So I would like to first welcome Susan Hillman. Susan is currently the professor of teacher education in the College of Education at Saginaw Valley State University in Michigan in the United States. She is a teacher trainer and her area of expertise is in mathematics education, and she has over 30 years of experience teaching future teachers on how to teach mathematics for grades from kindergarten to the middle school. And her primary responsibility is to actually support teachers in ways so that they know ways that engage students in doing mathematics while learning mathematics along with meaning. And as a teacher educator, she is a part of a group which does a lot of work with having goals of continuous improvement of teaching practices, and especially teaching future teachers, how to write feedback to students, how do you question, how do you sustain discussions for learning to teach mathematics. These are her main focus of the work as she prepares teachers for teaching mathematics. And actually, of course, she herself started as a mathematics teacher, and she's worked in diverse backgrounds with different kinds of children, and she's taught mathematics for several years. And another thing that I would very importantly want to point out here is Susan has a lot of experience having worked in schools in India and also in training teachers and also preparing mathematics curriculum for Indian schools. So she was connected with Adhyayan, and in the last 20 years, she has traveled to India very many times. And she's also been one of the lead assessors for Adhyayan school reviews. And so being a lead assessor, she's traveled throughout the length and breadth of the country and seen various types of schools and reviewed schools and helped them in their improvement journey. So today, what Susan is going to really talk to us is, of course, share her experience, but it's going to be very much rooted in the context of what the schools and the kind of mathematics we do in our schools. So it's going to be rooted in that context. So thank you so much, Susan, for accepting and to join us today. I know it's early in the morning in the US, And you've woken up early morning to be with us, and it's such a delight to have you. Thank you so much. Yeah. So we also have Tom Power. So for those of you who were present in our previous session, a fortnight back, in the literacy session, Tom Power was again with us, and he shared a lot of meaningful insights into what literacy really looks like. And Tom also has more than 20 years of experience, and Tom has been a teacher educator throughout. And his experience lies in the design and delivery of EdTech, enhanced teacher development research and program delivery in the global South. He leads the International Teacher Education for Development Research Group at the Open University in the UK. His research is at the intersection of mobile learning, teacher education, and international development, developing innovative approaches that are capable of large-scale, low unit cost, and high impact and excellent VFM. In his role as academic director of the FDCO-funded English in Action program in Bangladesh, he led a team of national and international researchers to conceptualize, design, and deliver the research, monitoring, and evaluation component, which tested the effectiveness of a model of EdTech enhanced school-based teacher CPD from proof of concept to national scale, using mixed methods, including a 2070 quasi-experimental study that he's done. So Tom has also led the design note on EdTech for QLEAP, the World Bank funding to Bangladesh. His most recent research project, funded by EdTech Hub, evaluated how mobile phones supported children's learning during COVID-19 in Zimbabwe. He's also published many journals, and he's very often a presenter at Commonwealth of Learning, MLearn and eLearn Africa, and he's been invited to speak on teacher education, education technology, and international development at Oxford, Cambridge, and Harvard universities. Thank you, Tom. Thank you so much for again willingly coming and joining us. We are looking forward to listening to you on your experiences of all of these numeracy projects that you've had in the Global South. Thank you very much. And we also have Pauline Tyson today. Pauline is also a colleague along with Tom, and she's a specialist in early mathematical development with over 30 years of experience in primary education in the UK as well as outside of UK. Pauline is currently working with Open University, CARE, and World Vision to improve the teaching and learning of early mathematics skills in schools and non-formal education settings across Zimbabwe, Malawi, and Sierra Leone. Here, Pauline has developed teaching and learning materials for children and young people and has authored professional development materials for teachers and community educators. She has contributed to a wide range of face-to-face workshops, field work in schools, and online professional development activities. Previously, Pauline inspired a new generation of teachers in the UK through initial teacher education courses and continuing professional development programs at Oxford Brookes University. And of course, in addition to her passion for mathematics and developing teachers for mathematics teaching, her other interests also include sailing, walking, and of course, adventures in her own caravan. Wonderful. That sounds exciting, Pauline. And thank you so much for again joining us. I know you and Tom are extremely busy. You have a lot of other things scheduled, but thank you for taking out time and joining us in our community of practice session. And once again, I just want to highlight the fact that all the three panelists today, though they are from the UK or from the US, what is really noteworthy is they have an experience and awareness of what is school education in our country and the education background that is there in our country. And so they are going to kind of share their experiences through the lens of what they have seen in either in our country or in the global south, maybe in Bangladesh or similar countries like in Zimbabwe. Thank you so much. And before I hand on to our panelists, I'm going to invite Annette to give us a Mentimeter link. And I invite the audience to just copy the Mentimeter link, which is there on the chat. Have you put it across, Annette?
Yes, it's already in the link. The link is already in the chat.
So there is a Mentimeter link on the chat. I request you all to copy the link and go on to a new tab on the browser and open the Mentimeter, and you have the first slide is, what does numeracy mean to you? What according to you is numeracy? If you could just quickly put in your thoughts, anything that comes on top of your mind. So let's take a minute or minute and a half for this.
Yeah, we've got responses coming in, and I'm going to share that very quickly. Yeah.
Yeah. Wow, I think the maximum number of inputs is numbers. So you see that right at the center. I also see some interesting input. There's one input like 25.
We're trying to decode the 25 problem that was given in the video.
Oh, that could be, yes, of course. Yeah, so counting numbers, number sense, addition, subtraction, of course, I can see a lot of those operations. Calculate, okay. Digits. I also see some coming on the chat, patterns, data. Knowledge of numbers, okay.
And there are a lot of them, ones that are very interesting about representations, numerical value, understanding data, understanding numbers, representation, ability to reason. So I think what is numeracy is a lot of things that are here right now. Yeah.
Yes.
So time for us to switch to the next one. Yes.
Yeah. So the next one is, what are the skills that you think we can teach our students through numeracy?
You'll have to just give me a minute to get back to it. Yes.
So
now
once
it should be active for everyone. Yes, just go back to that. It's active now. Because I've changed the
request you to go back to the same Mentimeter link, and then you'll have the next slide showing up there on your screen. What skills can be learned through numeracy or can be taught through numeracy? Are we getting inputs?
Yes. Just one second. Sure.
Oh, yes. So I see logical thinking right at the center, understanding. Okay. Rational thinking, calculations, reasoning. Analysis, of course, yes. I also see some on the side, perseverance. I love that.
Problem solving. Architecture.
Yes, architecture, of course. I see the same 25 here as well. So I'm just wondering. Very interesting.
You can use the chat to put down something that you want to convey for the 25. You want to decode that for everybody, whoever's written it, you can definitely elaborate on the chat as well.
Yeah, please do. And I'm sure the inputs on these two slides for Tom, Pauline, and Susan, this is going to help you. And, in terms of understanding where our audiences are, in terms of what they think about numeracy and the skills that can be imparted through numeracy. So I'm going to now at this point hand over to Tom. And I again urge our participants to continuously keep the chat flowing. Please continuously put in your thoughts, your questions. We would love to address your questions towards the end. We'll take out a few minutes for that. We'll have the panelists address your questions. So we would love to see it flowing. Yes, over to you, Tom.
Thank you. And Jayshree, do you want me to present the slides from my computer, or are you and Neha going to do that?
Tom, you could do that if you're comfortable.
Okay, if you just bear with me a second. Sorry, I wasn't ready to do that, but just give me a moment.
I could also.
There we go.
Yeah, okay, fine.
And I think if I click present there, that will hopefully work.
Yes, you're able to see it.
That's great. And sorry, just let me, it's come up on the wrong place. Just let me try and move that if I can. No, I can't. Okay. Right. So I'm just going to spend a few minutes to kind of set the scene for numeracy and learning as a background, and then Pauline will come in and give some specific examples of approaches that we've taken to that within the international teacher education programs that I lead. And yeah. So just picking up on the question that we were looking at in the Mentimeter a moment ago, what is numeracy? And for a long time, numeracy has been seen as a parallel to literacy, as an ability to cope with mathematical needs of daily life. And for those who were here 2 weeks ago when we were looking at literacy, you'll remember that literacy was initially conceived as a set of cognitive skills that were kind of independent of any context. And then increasingly over the years, they've become to be seen as skills that are exercised within a context of daily life, and they have a kind of functional relevance to daily life, and that's reflected in here. So it's not just the skills that you're learning in numeracy, the addition and subtraction, and all the other things that came up on Mentimeter, but it's the ability to apply those skills within meaningful contexts in daily life. And more recently, the emphasis on that understanding of numeracy has been to see that there are actually very diverse ranges of situations that those skills need to be applied in your personal life, in society, in work situations, and also an awareness that the numeracy needs that children are going to be faced with throughout their lifetime are likely to change in a rapidly changing society. So we need to see the development of numeracy skills in the context of everyday life and a wide range of different situations, but also to understand that those contexts are likely to change significantly over coming years. And within the program that I lead, our approach to numeracy is to look at numeracy as a network of connected skills that enable problem solving in real world situations. So it's the notion that these skills are interconnected and that they're helpful for dealing with issues and challenges in the real world. And when we say that the skills are interconnected, as a simple example, if you know that 3 + 2 = 5, you also know that 5 - 3 = 2. So the skills of addition and subtraction are not separate, they're interconnected and interrelated. And similarly, if you know those things, that leads into multiplication and division. All of the skills are connected together, they're not discrete, separate kind of processes. We understand that fluency in number facts, like the ones on screen, is developed through familiarity, through practice, You can use games and things like that to develop those familiarity. It's not about memorizing these facts. It's about repeated exposure and opportunity to practice and become familiar with numbers and the way that the numbers fit together and work together. And we think numeracy is absolutely crucial because, as we said a moment ago, it's necessary for solving problems in the real life. So when we're teaching numeracy, we're trying to situate that in the context of real life and problem solving. And people need to be able to apply numbers to managing their finances for practical household activities, understanding things about health and growth and development, to be able to take their role in the world as a global citizen, and for work. And when we think about work, particularly for STEM subjects, but all work requires number in one way or another. It's particularly so in terms of STEM. And there are big issues around gender pay gaps and children's choice of science, technology, maths related subjects. And also the prominence of number skills for future economies and the subjects that are important for that. So there's very kind of political issues around the development of number sense and number skill. And perhaps most tellingly, children's early attainment in numeracy is the biggest predictor of their later academic success. So the more children we can help become confident and competent at using number in early years, the more children we're likely to see being successful in their academic career throughout their lives. Having said how important numeracy is both for learning and for life, one of the things that's become increasingly apparent around the world over the recent years is just how many children are getting to the end of their schooling and not being proficient in basic number skills. And there's a study by UNESCO in 2017 that suggests, as its headline says, worldwide, more than 1/2 of all children and adolescents are not learning. The UNESCO Institute of Statistics has looked at the available data, and their estimation is that if you look at all of the children in the world, by the time they get to the end of their primary years, more than half of those children won't be proficient in basic number skills and in basic literacy skills. And that's, for most of those children, it's not because they're not in school. They're getting to the end of primary education and still not being able to be proficient in basic number skills that would be taught in kind of infant level schools. And the World Bank has taken this up in the last 2 years, and they've framed this as learning poverty, children who are getting to the end of their primary age and not being proficient in number or in literacy. And the diagram here is adapted from a World Bank paper last year, which is trying to estimate what the impact of COVID will be on that. And they're estimating that at the end of COVID, it's possible that in low and middle income countries, almost 2/3 of children will be in learning poverty, will be on track to get to the end of their primary years without having developed these skills. And as you see, only 1/10 of those children are not learning because they're out of school. Most of them are in school, but not making the progress that you'd expect. So improving numeracy learning becomes absolutely crucial. And I know Pauline is going to give some practical examples of this in a moment, but just in terms of how do you help children develop numeracy skills and become confident in number? And I just want to share some of the highlights that have come out of literature on numeracy learning over recent decades. And one of the most important things is about making connections. And that is both in terms of connections between the different numeracy skills. So as I said earlier, that addition and subtraction are linked, they're related skills. Multiplication is linked to addition, division is linked to subtraction, that making those connections between skills, but also making connections between doing numeracy problems with physical objects, doing numeracy problems with images and with symbols. So those making connections and handling numbers in lots of different ways is a crucial aspect. the number sense, as I mentioned earlier, repeated opportunities to practice, to become familiar and comfortable with manipulating numbers, so that you just know that 3 minus 2 is 5. You don't have to calculate that, you just know that because you've got repeated experience with those numbers. I mentioned contract, pictorial and abstract representations before under making connections, but using objects, pictures and symbols to handle number. Sometimes people think they're kind of stages, that you start with using manipulating physical objects like counters or beads, you move to pictures and you end up just working with symbols. But actually there's a lot of evidence that even at later stages of learning, it's still very helpful for children to work with concrete and pictorial representations of number problems as well as with abstract symbols. One of the most crucial things would be starting with where the learners are. And in the work that we're doing in Zimbabwe, we have learners very often who are most of the children in the class would be struggling with, say, subtraction, and you come across a teacher who is trying to teach negative numbers or multiplication of fractions, and so, well, they're just not going to be able to learn that until they've got the foundation. So let's go back and work where the learners are. And then when children are learning numbers, it's really important that they have opportunity to talk, and talking about the numbers helps them express their own ideas, clarify their thinking, but also communicate with others and solve problems together. So we view learning as a sociocultural process. It's something that is active, that is done in collaboration with others, and it involves communicating about what you're learning. And finally, very often teachers emphasize procedural fluency. So as Neha was mentioning, you're taught a procedure for how to do division, but you may not necessarily have a conceptual understanding of what it is that you're doing. And at the other extreme, it's possible to teach the concept but not pay enough attention to the procedure. And to be effective, children need to learn both the procedural process for doing the calculations, but also the conceptual understanding of what they're doing and why they're doing it in the way that they are. And I've overrun by a minute, sorry about that, Pauline, and over to Pauline, who's going to take this forward. Pauline, do you want me to keep going with the slides for you?
I think that'll probably be easiest, yes, if that's
Okay.
all right with you. Is my sound coming over well enough? I'm on an unfamiliar computer in an unfamiliar room, so I just want, is everything sounding good? Yeah?
Yes.
Okay, perfect. Okay, so what does all of this theory look like in practice? We're going to look at this through the lens of a project that we've been working with our colleagues in Sierra Leone. We called it the My Book Project, and this was designed specifically to address the massive challenges that that Jay referenced earlier of the COVID situation, where a lot of children are simply not able to go to school and are therefore missing out on massive chunks of really important learning time. And so we worked with our colleagues from Sierra Leone to create a new way of learning, where learners could perhaps learn from home, or at least keep the kettle boiling, if you like, so that they're continuing to keep those skills at the top of their minds for when they did go back to school. This would be very new in that there'd be very little external facilitation, maybe a phone call once a week to check on how the learners are doing. Perhaps in a more ideal situation, learners would be working in small groups with a community educator, but never has there been a more important time to be focusing on learning rather than teaching. I love the fact that this is not called what does good numeracy teaching look like, but what does good numeracy learning look like? And I think if we focus on the learning, the teaching is going to improve. It's all about the learners. So I'm really loving that. And so let's just go through, if you could walk through with me. We're going to look at the topic of equivalent fractions and the way that we've addressed this within the Sierra Leone My Book project. So Tom, if you could go on to the next slide, that would be great. Thank you. So traditionally, in a textbook, you might find these sorts of questions, completely abstract questions. There may be a few children who have learned a procedure that will help them to understand how to do this. Unfortunately, procedures, if you don't use it, you lose it. And there's so many procedures, actually it's very easy to get muddled as to which one is which. And for an awful lot of our learners, that's just not going to cut it. They're not going to have that conceptual understanding that's going to enable them to come back and to use this knowledge in a different context. So, and certainly it's not going to work for learners who are at home without the mediation of a more knowledgeable other. So what can we do about that? Can we go on to the next slide, Tom? Tom was talking earlier about making connections in mathematics, and Haylock and Coburn have designed this really powerful image that I think just summarizes all of these links and connections. The research tends to indicate that if there is a connection between the symbols and the pictures and images and the concrete experiences and the language of mathematics, all of those different representations of mathematics being used at the same time and with links being explicitly made and designed within the materials, learning deep conceptual understanding and procedural fluency are developed, and that results in lifelong learning that can be transferred across a range of different situations. So let's unpack that and see actually what that looks like in reality. Tom, if we can go on to the next slide. I would like you now, if you've got your piece of paper, if you could pick up your piece of paper, I'd love you to just go through a little walk through with me. This is one of the pages from the My book. There's a learner book, and there's a book for a community educator should there happen to be one. But this is from the My book. So let's assume that we're a learner at home trying to learn about equivalent fractions. In fact, trying to understand what the concept of fractions is all about. So we need a piece of paper about this size of a page from your exercise book. So let's fold it in half. Two equal sized pieces. Then open it up again. Now on one of those equal parts, we're going to write 1 part out of 2. So we're going to put a 1 and then a line to separate it and then a 2 underneath. So that's the symbol that we've got there. We've got an image. We've got a picture on the page that's going to help us to understand this. We've got our concrete resource. We've got our piece of paper. We're now going to directly make a connection there with the symbol 1/2. And then it says there are 2 halves in a whole piece of paper. We're making that connection with the language. We're using the word half, and we're connecting it with the fact that there are 2 equal parts. Now we're going to fold it again, making sure that all the parts are equal. And of course, if there was a teacher or a more knowledgeable other to be mediating this, some kind of facilitator, there would be a much greater use of language within this project. The language has to be very simple because learners are trying to understand it for themselves often on their own. So now we're going to write in one of the boxes, we're going to write 1 part out of 4, because we can notice that now we have 4 sections in our whole. There are 4 quarters in a whole piece of paper. Now fold it in half, fold it in half again, and now fold it in half yet again. And open it up. Are you all with me so far? Excellent. Now I can see that my paper is divided into 8 equal parts. I'm going to choose one of those parts and write 1/8. There are 8 eighths in a whole piece of paper. So now we're getting a conceptual understanding of what an eighth looks like and what a quarter looks like.
Piece of paper.
And okay, so can you see there how, Tom, can you just move back to the previous slide for a second? No, the previous slide, sorry. Can you go to the Haylock and Coburn? That one. That's lovely. Thank you very much. So you can see we've connected the symbols and the pictures and images and the concrete. On this occasion, it's the concrete manipulatives of folding that piece of paper and getting an understanding of the relative sizes of the different fractions. And we've been talking about it. We've been using the right sort of language. We've been identifying the fact that 1/8 is an eighth, 1/4 is a quarter. So we're making the connection between all of those things together. Okay, can I just ask you to hop along now then, past the slide we were just on, Tom, on to the next one. That's perfect. So now perhaps we're in a position to be able to answer those questions that we asked as an abstract concept before. How many quarters are there in 1/2? We've now got our piece of paper that gives us a really clear visual image of what a quarter looks like. And I can see that there are 2 of this quarter size sections in a half. How many eighths are there in 1/4? I can see that I can count how many eighths there are. Or I might by now have started to make a connection. If I know a little bit more about multiplication and division and how numbers work together, I can start making those connections myself and developing that understanding. If there is a teacher there to mediate, the teacher might be saying, "What do you notice?" and helping learners to see the patterns of the numbers as we're asking those questions. But we're now in a position to be able to access these questions on a multitude of different levels because there is no one way of learning maths. So on to the next one, please, Tom. So what we've done so far is we've looked at nuts and bolts, if you like, of what fractions are, how they work together, their relative sizes, what we call them. We might have noticed things like when the number at the bottom gets bigger, the size of the fraction is smaller, that there are more of them. And so we're starting to make those kind of connections. In the Haylock and Coburn model, it said concrete representations. That doesn't just mean the manipulatives. It actually means those situations that Tom was talking about, putting it into a real life context. And we worked with our Sierra Leone colleagues to work out what sort of things would actually mean something to these learners who are out in a village context. And one of the other connections that was really important and remains really, it's a real passion of mine, is linking literacy and numeracy. So we wrote this series of 12 units for 12 weeks of work, and the story that ran through supported both the literacy and the numeracy elements of the program. And so here I'd like you to meet grandmother and Fat Marta and Moses, and they're the lead characters in our story. And basically there's a little bit of a thread that goes through the story of the family is invited to a wedding, and then they have all sorts of problems that they have that brings up various different numeracy concepts. And one of the things they have to do is they want to make clothes for the wedding. And so here we've got the direct application of our fractions. We need that information about equivalent fractions, but actually what we're doing now is we're adding fractions. We're adding fractions with different denominators, and we're adding mixed fractions. Now, I don't know about you, but when I was at school, I found those concepts quite challenging because they were put in the same way as they are in that little blue box at the bottom of your page. Abstract concepts where I had a procedure that I had to follow, and sometimes I couldn't remember the procedure. So right here at the bottom of that page, you can see it says you can use the folded paper from part 1 to help you add the fractions. And what it also suggested, but I haven't actually written it on here, you can cut the paper up if you like. And so I can perhaps have a half that I've cut up and a quarter that I've cut up, and I can put them together and I can see that that makes 3/4. Something that might have been a procedure before, I've now got a visual image in my head that's helping me to understand what I'm doing there and why on earth I would want to convert that half into quarters. So what we found, and we've used this sort of principle within a lot of the other programs in various different parts of sub-Saharan Africa, is that learners, it makes sense to learners. They've got a context, they can see a reason why they would be doing this, and they've got the tools and the visual images to be able to understand what they are doing within it. So they've got the why and they've got the what. And it's building in small scaffolded steps on what they already know. So they're not having a leap of understanding from one pole to another pole. It's gently leading them through and helping them to discover for themselves how those connections work within mathematics and how actually it's a fun subject to do. So if we can go on to the next slide, Tom. I can't emphasize enough my passion for this wonderful little diagram. I passionately believe that when learners are taught to connect all of the different things together, putting the concrete experiences being not only the manipulatives, but the contexts that are meaningful for the learners, I have an absolutely passionate belief that that 2025 target for foundational literacy will be able to be met. So Tom, I'm going to hand back over to you.
Tom, you're on mute. You'll have to unmute yourself.
Thank you. Neha, I think we're not going to stop for questions now, but we're going to go on and do that at the end. Is that right?
Yes.
Yeah, thank you.
However, at this point, we could just take about 30 seconds and everybody could, assimilate all that Tom and Pauline have said. And if any reflections or questions that you may have, you could put them on a chat in the chat. And don't forget to take a few sips of water as well. Keep yourself hydrated. It's really hot here where I am, so I'm constantly reminding myself to do that. Yeah. So maybe 30 seconds before we go on.
It could be your thoughts, any questions that you would want Tom or Pauline to address later on in the session, or something that struck you, or even if if it's something that you've done, a similar thing that you've done in your class, in your school, it could be that as well, something from your experience, anything that comes to you now at this point in time, you could just type in the chat. We would love to hear your voice through the chat. Yes, Sushma, formative assessments can be designed. Yes. So keep it coming while we have Susan getting prepared. Susan, you would want to present it yourself, or you would want Neha to share your presentation?
No, she's presenting it.
You'll do it yourself?
Yeah.
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 I'll share.
Thanks.
So if it's all right, I'll go ahead and share my screen.
Yes. Yes.
All right. So I am actually, let's see, I see which one is shared. I just have to, so I have a new setup that I'm still getting used to with an extra monitor to the right here. And this is the first time I think I have been on Zoom and using the separate monitor at the same time. And I want to be looking at the camera. So I think I'm going to do, I'm just trying to arrange my screens here. All right. And so that was wonderful to go through those two pieces. And I think I've got a piece that will complement what's already been done. So I've been thinking a lot about what does good numeracy learning look like? And I have some experiences to share, and I'm going to keep my slides in the edit mode. Normally, if I was teaching my class, we would interact and my students would be interacting and editing on the slides as well. But we have such a large group today. I'm just going to share, and I may do some editing and typing as we go along. So, so I'm going to.
Susan, are you sharing your screen?
Oh, I thought I was.
I'm able to see only a white line.
Yes.
Is that what it is?
Me too. That's right.
Yeah. Okay. Now it's come. Now it's fine.
I'm sorry.
No worries.
Okay. Yeah. So so I'm going to share some experiences first. So my first experience is what happened here. So I have two little stories. The first story I want to tell is on one of my visits to India, and I was working with a school, and the College of Education for Teacher Training was also there, and I was asked to give a demonstration lesson to a group of 4th grade students, and so I, in front of the future teachers and the faculty of the College of Education, and I think some teachers from the school had come too. So I talked with the teacher ahead of time about where they were in the textbook, where they were in their math learning, and I prepared a demonstration lesson that I thought would build from what I had seen prior to that particular lesson that the students were working on. So I developed the demonstration lesson, and I did it in this, so I taught the lesson and it totally failed. Like, this lesson just didn't work. And so I'd asked the students to think about something, and I'd posed a problem. It was a story problem, and I'd asked them to draw a picture and use the picture to figure out the answer. And so so as I was walking around during the demonstration lesson, nobody was drawing a picture. Some people had used the algorithm, figured out with the numbers, but nobody had drawn a picture. And so I was trying to figure this out, like, why aren't they drawing the picture? And so I was trying to encourage them to draw something related to what they could make sense of in the problem. And I saw that a couple of students, just a couple, started drawing, like one of them started drawing a girl because there was a girl character in the problem, and somebody started drawing something else, but it wasn't related to the numbers in the problem. It was related to the situation. I thought, well, this is interesting. So I worked with what we had and finished the lesson in some manner, shared it. And then, of course, there was the debriefing time with all of the teacher training faculty and the future teachers. And so we talked about it, and I said, well, that didn't go how I had planned, how I had thought it might go, and talked about how visualizing what to do with the numbers is really important, as well as knowing how to work with the numbers. So that was an event. And later on, when I talked with the classroom teacher, and I said, I thought maybe the students had this experience, which was prior in the textbook to this lesson. He said, oh no, we skipped that. We skipped drawing the pictures because that's not on the test. So we went right to just learning the algorithm. And I thought, oh, okay, that's why the lesson didn't work the way I thought. And okay, so that was in India in 2014. And of course, I work with future teachers all the time in my classes and work with teachers. And so just recently, this past semester, we just ended our term a couple weeks back. And this semester, one of my students was planning lessons for the classroom in which she was a first-year teacher. And she was teaching division of fractions. And so she had done her plans, and she had the page from the workbook, the student's workbook, and she had circled the exercises that she wanted the students to do. And then on this particular one, so the image we're seeing here is she had written, nope, like we're not doing this one. And I saw that was interesting because the ones that she had included for the lesson were all of those bare number exercises, like what Pauline had pointed out, typically in the textbook. And what this teacher had decided not to do was this problem where it is so important. This problem was asking for 1/2 divided by 3 to describe a situation that this could represent. So this is kind of working backwards a little bit. Instead of giving the story problem and asking the students to do the work, it's saying, here's the problem, but what's a situation? Like, what's a situation where we could take half of something and divide it into 3 equal parts? And so, and then once having that description or that situation, drawing a diagram, like drawing that picture to show the relationships and actually using that representation to find the solution. So there's nothing here about applying an algorithm. There's everything here about understanding the situation, building that conceptual understanding piece to then figuring out what to do with the numbers. So I find that really interesting that this isn't just something in one particular place. This happens across the world, I suspect. And so, you know, how can we help people think about what are the important pieces? So all of those connections that Pauline was talking about are really important. So we're not going to do this today, but this is just one of the things I do with my students. We make it interactive. And if you want to use the chat feature, I'll be able to catch up with the chat later. I'm not able to view the chat right now, but if you want to think what could be a situation for 1/2 divided by 3, I just put one simple example there. Go ahead and put your own story problem in the chat, and I'll be interested to look at those later. So what I wanted to just kind of summarize, and I know there's a lot of words on this page, but how is numeracy defined and what should it look like? Tom gave some really important definitions that are around there. And I was looking in the National Education Policy and thinking, what does the National Education Policy say that numeracy, this foundational numeracy is? So I picked up some quotes from that document, and it said, the ability to carry out basic addition and subtraction. It talked about counting arithmetic, and I highlighted here mathematical thinking. And I thought, all right, that sounds really important, and shapes and numbers. And then later on page 17, it talks about the aim of assessment. And we know assessment drives instruction, right? If it's going to be on the test, then it's something that we usually attend to. We'll shift from rote memorization to competency-based, and I highlighted again, critical thinking and conceptual clarity. So if we put this in the context of, you know, what does good numeracy learning look like, then we need to think about how do we build in this critical thinking and conceptual clarity. And I think making those connections across symbols, language, experiences, those are the kinds of things that are going to be helpful. And of course, because I'm in teacher training, continuous professional development will cover the latest pedagogy. So hopefully we can combine a couple of things here. I just wanted to contrast that with some things that are common in the USA. So we have a set of standards that guides our curriculum in the United States, but I would say most people focus on the content, but these 8 practices for doing mathematics are where that's where we build the conceptual understanding and engage students in actually doing math, not just viewing math, viewing their teacher doing the mathematics. So making sense and persevering, reasoning is big, modeling with mathematics, so representations are really important, using tools but strategically, so there's some ways to make decisions about things. Attending to precision, absolutely, we want to be accurate, and looking for structure in the numbers. So when we think about adding and subtracting and multiplying and dividing, and particularly in that video that we watched at the beginning of this session, like one of the things that I'm thinking about there in terms of looking for and making use of structure is place value, right? So when we think about 14, 14, 14, 14, and 14, if we're thinking about those ones as ones and not tens, right? That's absolutely where the confusion comes in. So looking for the structure in numbers and pulling them apart in tens and ones and thinking about how to use numbers strategically would be important, and part of what I would consider critical thinking and conceptual clarity in looking at numeracy.
Susan, just a minute, if you could just go onto the present mode, I think it'll get readable.
It'll be easier?
Yeah. Top right, present.
Yeah. Okay.
Is that okay? Or do you?
Well, it limits me from writing, and I wanted to.
Okay. Then that's fine. That's fine.
But I can, yeah, maybe we can come back to this.
Yeah, that's fine. No worries.
Okay. So, so let's do some thinking. So one of the things that I'm going to talk about is a number talk. Now, this is something where it would be part of a program. So although I think story problems are very, very important, this type of routine is about the numbers and about the number relationships. So focusing in on the strategies for addition, subtraction, multiplication, and division. And this can be something that can become a daily routine for about 10 minutes in math class. So we're going to try one. And again, this is a little bit different than what I might do in my class, but sort of modified for the experience that we're in right now. So one of the things that we're going to do is a number talk is about mental arithmetic. So, so no calculators on your phones, no paper writing. I want you to think, right? We're going to think strategy. And so what I will do is I'll reveal the problem. It's under this black box. I'll reveal that shortly. And I will give you a little bit of time to think about it. And then I will give you some further instructions. All right. So I will reveal the task. So one of the things that is really hard for teachers sometimes is to be quiet and allow students to have time to think. And I'm not sure I've given you enough time to think yet, but but I'm gonna go ahead and say, if you have an answer to this problem, go ahead and type it in the chat, but don't send it yet. Let's give everybody a few seconds to type in the chat what you think the answer is. And then I'm not able to see the chat, but go ahead, everybody send. And then maybe Neha can report out to me and say what are the answers coming through in the chat.
27. Unanimous answer 27.
Okay.
Everybody's been putting in 27.
Everybody agrees. All right, fantastic. Sometimes, of
okay,
course,
we have one. Is 83. Okay, so 27. Okay.
Okay. And you know, sometimes different answers come through. Sometimes there are different answers, and that's something that when we work with children, especially, we can anticipate that there might be some different answers that come up. But if there's a unanimous or everybody is pretty agreeable on 27, that's great. So what I would like to do now is, all right, here's the problem. I didn't want to reveal it ahead of time. So it looks like people are giving the answer of 27. And if there were other answers, I would list those as well. So now I'm interested in hearing some strategies. And Neha, I'll take your advice on this, whether people unmute or whether just give a strategy in the chat. What do you think?
So we have one strategy that's been put in the chat by Akta. And I can read that out. It says 56 plus 4 is 60, plus 23 is 87. Is it 83? So 27 is what she has put in.
So 83 subtract 60 is 23. Was that it?
Okay, she says 56 plus 4 is 60, and then plus 23 is 83.
Oh. I'm sorry.
So 27, yeah.
Got it. Starting with a 60 plus 23 equals 83. And then taking the 4, yeah, got it. Thank you.
We have one saying 13 minus 6 is equal to 7.
Okay.
70 minus 50 is equal to 20. 70 minus 20. 70 minus 50 is equal to 20, and 20 plus 7 is equal to 27.
Okay, all right. And though I'm writing it out this way because I'm limited to typing at this point, we could imagine this one seems to follow, like if we had stacked it, right? If we had stacked it, we usually think about regrouping, and we might have regrouped some things there. The 80 changed it to 70, made this 3 and a 13 to do the subtraction. Okay, all right. So we could go through and do some different strategies, but this is what a number talk is.
Yes, Susan, there are many in the chat, so it's great. You have got lots of responses.
Excellent.
Thank you everyone for sharing.
I appreciate that, and I will definitely take a look at those later. Hopefully we can save the chat. For now, I just want to say, so this is what a number talk is. Like it's a brief, it's not long, it's like 10 minutes, posing a problem, giving time to think, having students share the answers. If there are multiple answers, then what we do is when we ask for strategies, we say, who can defend? Who can defend the answer of 27? Or tell me which answer you're defending. And so sometimes students will defend a wrong answer, but in the process of doing that, they will be able to self-correct and say, oh, I see what I did there, and they can correct it. And that's one of the most powerful learning experiences, is when you have made a mistake and you can figure out, or with the help of others, figure out how to fix it. And so number talks can provide this rich set of ways of thinking about the numbers and ways of being flexible in pulling apart numbers, putting them together, keeping track, and so forth. And so, for example, when Tom was mentioning procedural fluency, we think about learning the procedure and learning the rules. But part of the fluency piece to that is thinking flexibly. So thinking flexibly, like different ways of working with the numbers. Also, it's about strategic, like making strategic choices. So depending on the numbers, you can make choices about what strategy might be more efficient than another strategy. And of course, accuracy is there too. So procedural fluency is flexibility, strategic, efficient, and accurate. So, so we can work on these skills as we work on number talks. So then what I wanted to do is I would like to share with you some visual representations, because again, that's something that I think can help students begin to make sense of the strategies in ways that that help them think about the relationships between the numbers and make connections. So in the visual representations, and I think I put out several here using some digital tools, and I don't know. So Neha, is this large enough to see?
Yes, it is.
Okay. So,
but it would be great if you can put it on present, like if you don't have
Let me
anything to write on. Yeah.
Okay. Yep. Okay, I can do that. All right. So, so for the problem was 83 minus 56. So one of the ways that we can represent this is to think about making the number 83. So I have 8 tens for 80 and 3 ones for the 3. And in this particular strategy, I thought of the 56 as a 50 and a 6, so pulling it apart into its place values. And then I took 83 minus 50, and when you have the blocks, it's so easy to just take these 5 tens and just pull them away or set them aside. And then I had to take away 6 more, but the way that I have it in the blocks, like it's easy enough to take away these 3, but then we still have to take away 3 more. And I could exchange this 10 block for singles and take the 3 away, or I can draw around it. There are different ways that I could represent it. So this is one strategy, subtracting the 50 and then subtracting 3 and subtracting 3 for subtracting the 56. Let's see if I can, there we go. So another way, another strategy, and I think this is one where both the numbers get an additional 4 added on to them. So I represented that by saying I'm going to add 4 onto the 83 to make it 87. So totally I have 87 represented here. But then I'm going to take away 60. So, whoops, sorry, I went too fast. Okay, I have several strategies here, and for some reason I am having difficulty going back to where I was. Okay, all right. So in this one, by adding 4 to both numbers, so I'm making the original number bigger, 83 became 87, but I'm taking away more than I needed to take away. I'm taking 60 away instead of 56. But 87 minus 60 is so much easier for me to solve, especially if I'm doing mental arithmetic, and it gets exactly the same answer. Because we can see that if I have 4 more to start and I'm taking 4 more away than I need to take away, the visual representation helps us see that even though both numbers got bigger, the answer, the distance between them, didn't change.
Yeah. So this was a strategy which one of our participants had typed in the chat.
Oh.
Add 4 to both numbers, yes.
All right, so here's a way to make that visual, right? And even if I had I had the blocks with me, if I had the physical blocks, right, we could actually work with them. I made these with a digital tool for number pieces, which you can also do in an interactive way. But I made all these pictures yesterday. So here's another strategy. Maybe somebody used this one as well. So I had the 83, the 8 10s and 3 1s, but I just added 4 to the 56 to make it 60, because 60 is easier to subtract. So I take the 60 away. Yep, I think we had something similar to this. And so I took the 60 away, but those 4 that I added on to the 56 need to be added on. Like, I took away too much, so I needed to put those back. Here's another one, a similar one, but this is adding on to the 83. So I put several here. We don't need to go through them all. I wanted to also show you that we can do this with number lines. And sometimes a way to make sense of subtraction is to think about what is the difference or how far from one number to the next. And when you think about it that way, a number line makes a lot of sense. And this is an example where we can see the difference between the numbers doesn't change. So if I add 4 onto the 56 and I add 4 onto the 83, the distance between 83 and 56 is exactly the same as the distance between 87 and 60, but 87 minus 60 is easier to solve. So this is the flexibility of thinking with number. And again, I don't know how we're doing on time.
Susan, we have a couple of minutes more.
Couple of minutes. Okay,
Yeah,
so
about
I'm going.
2-3 minutes.
Yeah, so I'm going to stop sharing that for a moment, and I'm going to go back to. Hang on one moment.
So I request the participants to put in your thoughts, questions.
Let's see.
Yeah, so I'm going
There we
to
go.
just spotlight everyone. Yeah, are we ready for that?
Yeah, so when I did have one last question. I'm sorry, I was just trying to. I'm a little bit of a novice here in navigating.
Okay, I'm going to take off the spotlight so that Susan, you find it easy to navigate. Please go ahead.
Sorry about that.
That's okay, absolutely fine.
Absolutely okay, it's okay.
All right. So so one of the things, and I'll go into the present mode here as well. So so one of the questions I had for people, and again, if people would respond in the chat, based on this little number talk experience that we had, or maybe you can imagine doing some number talks with your students or with classes in your school. And I'm just wondering, so what kinds of mathematical thinking did you see examples of, or think about, or hear? Because the National Education Policy says mathematical thinking. Part of it is mathematical thinking. So I just would hope that maybe people could share a little bit, and I'll just pause for a moment.
You could type it in the chat, or maybe quickly unmute yourself and just say whatever comes to your mind. What kinds of mathematical thinking did you hear? Yeah, we get it. Problem solving, that's one, Susan. From Deepti, we hear problem solving. Logical thinking. Reasoning. Experimental learning. Okay, experimental learning. Critical thinking. Yeah, so related to daily life.
Yeah, So I really appreciate what people are thinking, because absolutely the number talk focuses on the mental arithmetic strategies, but after the number talk, having some time to, or even when students are sharing their strategies, to have them physically represent or use some ways of representing the relationships between the numbers would be helping to solidify their number sense and conceptual clarity. Like, what does it mean 56, 5 10s and 6 1s, for example, and how can we subtract that? So, so I appreciate what people are sharing. And one of the things that if people are interested and you can talk with me, there are ways that you can do number talks online, because I know in the pandemic situation with COVID, a lot of us may be teaching online or using online platforms. So doing a number talk online, there are some really great resources for having students interact if you're able to do a synchronous online class. And I'm open for questions. So I think maybe I'll just stop it there, and thanks for participating.
Thank you so much, Susan. So any quick questions? We have about 5 or 6 minutes. We could ask any questions that are there in your mind, and we have Pauline, Tom, and Susan to take your questions.
So we had one question in the chat. Hasina asked for some methods to teach numbers in an easy way. I'm sure, Hasina, your question kind of got answered with the strategies shared by Pauline as well as Susan. There is one question by Sushma asking if abacus was a good way of teaching math. Is that something you would like to take, Susan?
So an abacus is just another way of keeping track of numbers, right? I mean, in some ways, it's a way of representing based on 10s, 5s, and 10s. And 5 and 10 are anchor numbers in our number system, our base 10 number system. And so relating numbers to 5 and 10 is really important. I think that helps develop the number relationships, the basic relationships that can help us design strategies. So when we do something like 83 minus 56, we can think about those numbers related to 10s, and sometimes knowing the 5s and the combinations can really help us out. I have an abacus, and I use it occasionally, but yeah, I think it can help students look at number relationships.
There's one question in the chat by Tulsi saying, I have a question. Some children get confused in solving signs and identifying them. Would you suggest a remedy for this, please? Tulsi, do you want to quickly unmute and explain what do you mean by solving? Are you saying the word?
Yeah, yes, ma'am. Some children feel difficulty in identifying plus and minus. So they get naturally they get that's the meaning of sign. So I wanted to ask you a remedy for that. Could you please suggest a remedy for that in identifying the signs?
So whoever would like to take that, Pauline, Susan, Tom.
But I certainly don't want to. I don't need to be the only voice here. But I think sometimes what I see is we rush to symbols before developing the understanding of the concept. So, so if we're thinking about developing the understanding of addition and putting things together, then lots of stories and objects and putting things together, and then we can introduce the symbol and use that to represent the words and the language that we're using around the situations and stories that we can tell about it.
Pauline, you want to also say something?
I think I'd just quite like to add to that, that absolutely, I completely agree that putting it into a context first and doing all the practical work first, but then I think that Haylock and Coburn making of the connections that while we're still doing all of that, we are introducing that plus sign, we're introducing that minus sign. And actually you can see maybe what I'm doing here. We're doing the plus, we're doing the minus, actually involving your body in it as you're saying it and as you are putting things together or pulling things apart, can be really helpful. And actually that's another thing, pulling it apart. You can see you're doing a minus sign as you pull it apart. All of those little things help to make the connections. I don't know whether that helps at all. I realize we're getting short of time, but early on, that question that I noticed going into the chat box and how does this work for number? Tom, I don't know whether you're in a position just to be able to bring up, I put another slide into that, our shared document, the one that's got bundles of sticks. And I'd just like to share ever so quickly. Have I got time for that, Neha?
Yes, a minute.
Okay.
Yes, of course.
Right. These are things that we're called how-to cards that we've been introducing into situations in Zimbabwe where there is no capacity for having online courses. These are printed cards that learners can take home with them and work with at home and then bring back for a community educator to look at with them. And I don't know whether you can see on there, these are little bundles of sticks. Well, what we found is that in every country, in every situation, people can find sticks. And it's a wonderful physical representation. Dean's blocks are great if you can get them and if they're available. The bundles of sticks, we have one stick, but then we can bundle 10 together and we can actually physically move those 10 into another column. And we can get that real conceptual understanding of what 10 means. And it avoids having that problem we had at the beginning where we thought that the 10 was actually 1 because it said 1, but it was in the tens column. So using bundles of sticks is a fantastic way forward. And, you can Google that and look at how other people have used them, but they can be hugely powerful.
Yeah. So there was one last question that I think we can take. It's on the chat. It's from Gauri. She asks, is there a concrete way of teaching LCM and GCD?
LPM and GPD, sorry.
Yeah, is there a concrete way of teaching LCM and GCD, lowest common multiple and greatest common divisor?
There's one way that that I have done a little bit with, and that I've seen done with different colored rods. So they're called Cuisenaire rods, is the brand name. But there are 10 different rods. Each rod is a different length: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And with those, you can use those to look for, there are ways you can use those to model LCM and GCD by putting them together. I don't have an example worked up, but I could probably share something, in a follow-up.
Okay.
There are also, I was just noticing somebody says about the story problems. You can also, of course, have story problems related to GCD and LCM, which can put them in a context, which can help make sense of what's happening.
And I think that looking at patterns and structures as you're developing understanding of multiplication and division is absolutely crucial in this as well. And so when you're looking at arrays, as quantities are lined up in rows and columns, you can look at the patterns and you can look at how you can make collections of those and make that number smaller. It's about developing the conceptual understanding alongside it.
Yeah, thank you. And we have a lot of observations and thoughts. There's somebody who says, just like Pauline, one needs to be a wonderful storyteller to be a math piece that Susan has shown for number sense. And the main takeaways are, making connections, using language, using symbols. All of this has to be connected to teach math. I think that has been the biggest takeaway from today's session. And of course, the whole idea that numeracy is not the same as mathematics. Numeracy is how a student is able to use mathematics in the right context, contextually in real life. I think that is numeracy has been the biggest takeaway. Yes, Tom.
Jayshree, if I
Tom,
could
you want
just
to
add,
say something?
yeah. There was a
Sure.
comment a while ago in the chat that said about moving from concrete to abstract, and this is something that you hear a lot.
That's
And
right.
I think one of the things that's come out from both Pauline and Susan's presentation is that actually it's not necessarily about moving from concrete to abstract, but it's about doing the concrete and the abstract stuff together at the same time and making the connections between them. So if for me, if people take anything away from that, it would be you don't leave the concrete behind and just focus on the abstract, like the question the children are lost with the addition and subtraction symbols, and they were lost because they'd moved on to the abstract and forgot the concrete. Bring the two together, make the connection between them.
And then you'll create visual images in your head that you can then keep pulling back when you've got the abstract, you've got the visual image from all of that other stuff you've been doing over the years. Yeah.
Thank you for that very specific thing about coming in and saying that, Tom. Thank you so much. So, and just for the audience, just a reminder, so today's was the second session of our 3-part webinar series. So the next is the final session, a fortnight from now, where we will look at what is the leadership role in implementing good numeracy and literacy learning in their school. So please do join us for that session. And thank you once again, Susan, Tom, and Pauline. Thank you so much for all your wonderful, deep insights about numeracy today. It was a wonderful session. And as you see, there has been a lot of takeaways. Thank you so much.
And the chat is full of thank you and appreciation for everyone. So have a good weekend, everybody.
Thank you very much.
Thank you very much.
Thank you, everybody. Bye.
Bye.
Bye.